Following on from the initial few videos on networking, this is just going to look at wireless networking, which works slightly differently because it makes use of wireless communication, Wi-Fi, and a little bit different in terms of the hardware. So the purpose of Wi-Fi is it enables devices to connect to a network wirelessly and transmit data wirelessly without any physical connection. Now that might seem straightforward, but that could potentially be a possible question in the A-Level exam. What is the purpose of Wi-Fi? So a wireless local area network is based on international standards, so that's what the Wi-Fi falls into, and there is a particular international standard that you don't need to know this for the exam, but it's what, as we talked about before, protocols. And a protocol is an agreed set of rules and signals, and it's a way that they can communicate with each other. So a follow-up question may be, what components are required for a Wi-Fi network or a wireless LAN? And the components, we need a wireless network adapter, and to connect to the internet, the wireless access point usually connects to a router. But we could have a wireless access point that is an integral part of the router, so it's actually built into it. So that's how we connect to a wireless network, through a wireless network point, and we have a wireless network adapter. Now there's ways in which we can secure a wireless network, and you may have heard of some of these before. We had WPA, which was Wi-Fi protected access, and WPA2, Wi-Fi protected access 2. So there's two security protocols and security certification programs, and they're used to secure wireless networks. The WP2A is built into a wireless network interface card, and that is much stronger encryption, and we have a 128-bit key generated. When we talk about a packet, we can think in terms of normal Royal Mail. We put a packet together and deliver it. Might call this a parcel, same kind of idea, but we've got data inside the packet. And you can imagine this being put inside an envelope, and on the outside of the envelope are the details of where this is going to and who it's come from. So the sender's address and recipient's address. And this is exactly in networking how packets work. Now each wireless network would have an SSID. This is the Service Set Identification. And it's the name of the local network. For example, My Network 791. You may have done this at home. You might have a network set up at home, and with your wireless router, it may be a default Virgin Media one, so it may have VM something on there. It could be a default Sky one with Sky and then the name of it, or you may have actually gone into the settings and changed the name yourself. The purpose is to identify network. It allows other devices, other people to join your network. And when you scan for possible wireless networks, you can choose one to join. Now it is possible to disable the broadcasting of your SSID. So if you want to hide your network so people can't try and join it, that is possible, and that's one added security of a network. Now we also have whitelists that we can set up within a router. We have whitelists and we have blacklists. Blacklists lists of MAC addresses that we do not want to be able to connect to our router, to our network. The whitelist is an opposite, so it is all the MAC addresses that are allowed to access our wireless network. So it's a way of controlling access. So in terms of security, if we've got a company, we want to operate wirelessly, but we only want a number of devices to be able to connect to the network, we would set up a whitelist. Alternatively, we might have lots and lots of devices that can connect, so we set up a blacklist of ones that we don't want to be able to. At Franklin College, we have a whitelist set up, so with the wireless network, you have to log on to the computer system and register your network in order to be able to put in your MAC address for your device, and that is tied to your user account in order to be able to use the wireless network. So that's really important to do. Now earlier on we looked at a collision detection for a bus network. Something very, very similar operates for wireless networks, and this is a protocol known as the CSMACA. Now this is the Carrier Sense Multiple Access with Collision Avoidance. If you remember from the bus network, it was about collision detection, because with a bus it was about seeing if a collision had taken place, sending the jamming signal and dealing with that collision afterwards. This is to avoid collisions completely, and it's a protocol for the carrier transmission in wireless local area networks. So it avoids collisions rather than detects, and it relies on acknowledgements to know if data has arrived safely. So for instance, a device may assemble a frame. A frame is just another name for a packet containing the information that's going to be sent, and you talk about that being framed. So it's been framed with the data in order to be sent. It listens out, is the channel idle? So is the wireless communication channel that we're going to send that data on, is that idle? E.g., is there no traffic on it at the moment? If it's not idle, we'll wait, and we keep going round in this cycle. If it is idle, so there's no traffic being sent, then we transmit the data, and that ends. So that is the main part of the CSMACA. Bringing in another protocol, the RTS and the CTS, this is a request to send and a clear to send. So during the wireless transmission, we wait until the channel is idle. If there are no other nodes, no other devices transmitting, then the station, the device that's wanting to transmit, will send a request to send. So it says, I've got a request to send, I've got an RTS. The WAP sends back a CTS. It goes, yes, it's clear to send. The channel is idle. This counteracts any problems of any devices that are sending. Now, on a wireless network, you've got to imagine a device might not always see the other devices connected to the main wireless access point. They may be protected. You've got Bob, Fred and Mary. They may be all transmitting data, they may be connected to a wireless network, but that doesn't necessarily mean they can see each other. And so we talk about hidden nodes. So these are nodes that the WAP knows about, but not the node that's trying to transmit data. So unlike a wired network, that node cannot look at other nodes. So these are classed as hidden nodes. So the RTS, it will send the RTS to the WAP. I've got a request to send. And the WAP will say, yes, clear to send. And at this point, they block all other data and devices from being able to send data. The data is then sent, and an acknowledgement is received. Once an acknowledgement is received, that cuts the communication. They know that that data, that packet has arrived successfully. If the channel is busy, then what the device will do is wait a random amount of time before attempting again. So that RTS and CTS are very important protocols to couple onto the CSMA C. And I've just noticed that says CD there, so I'm going to change that to CA because it is CA. Okay, that then gives the outline of wireless networking.